Hello. Today we're going to look at slopes of lines that ties in here with our parallel and perpendicular unit. So these next couple of sections are going to be reviewing some of those concepts you learned in Algebra 1 to tie in here with what we're learning in geometry. So this particular section we're going to focus mainly on slope, and then our next section will be writing full equations of lines. So let's start first with some vocabulary here and just kind of remind you what slope is. So slope, I'm going to actually begin with what letter we normally indicate slope to be. So slope we usually designate with the letter M. So slope is the ratio of the vertical change to the horizontal change between 2 points. Slope, the ratio between the vertical change and I'm going to put in parentheses, so vertical, when we think slope, that's what we usually call the rise. So it's the ratio between the vertical change, which is the rise, to the horizontal change, which is the run, to the horizontal change. So in parentheses, I'm going to write the word run between 2 points. Between 2 points. Okay, so that vertical change, sometimes we refer to that as change in y over change in x. So you may or may not have seen this notation before. So it looks like triangle y over triangle x, but this is really a Greek letter. This is delta, but it means change, and you'll see that in math and science as you progress. So change in y over change in x. That's the same as what you're used to as rise over run, or it's the same as that slope formula you've used. y2 minus y1 over x2 minus x1. Okay, these all say the same thing. So think about y2 minus y1 in this diagram over here. When you subtract the two, that's how much you have changed between one point to the other. It's another way of counting. And then the same idea on the run. So a lot of times when we're presented with this type of a problem, calculate the slope, we go for the slope formula. You could graph it if you wanted to, but that slope formula is useful so that you can quickly calculate slope. All right, so if I go ahead and run through that formula, if it helps you to do this, x1 and y1, x2 and y2, go ahead and do that. If you don't need to label it, you don't have to. So I've got 4 minus 9, my y2 minus y1, over 5 minus 3. So that's going to be a negative 5 over 2, and I can't reduce any more than that, so I'm going to call it good. Now, you could also have done the 9 minus the 4, but then I would have had to start with the 3 minus the 5. I should still get a negative slope, okay? All right, so that's kind of the basics on just calculating slope. So let's talk about parallel lines and perpendicular lines. So we have a couple postulates here, but these ideas you guys have already studied in Algebra 1. So let me read through the if-then statements, since that's the way our postulates and theorems are set up. Okay, so the slope of parallel lines. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Now notice this is a biconditional. All right, so in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. And then it goes on to say any two vertical lines are parallel. They also have the same slope. Okay, so key element here, if we are working with parallel lines, they have the same slope, okay? Also, look at your picture. See the parallel marks here that have been added? So if I can determine the slopes are the same, I know the lines are parallel. All right, slopes of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So let me show you, you don't talk about that a whole lot in Algebra 1, being that the product is -1. You talk about that more as being opposite reciprocals. So let me give you an example. If I take 2/3 and I multiply by its opposite reciprocal, let's go to this language. Let me back up. They are perpendicular if and only if the product of their slopes is -1. So let's say I have the slope of one line is 2/3. My second slope is -3/2. When I multiply this out, I get a -6/6, which is -1. So that would tell me that these are perpendicular lines. Instead of having to go through the math here, what we kind of back up to is we say that if you have two slopes that are opposite reciprocals, they're perpendicular. So I'm going to write out here opposite reciprocal. Okay, so if they are perpendicular, they are opposite reciprocal. So opposite sign. If one's positive, the other's negative. Reciprocal would be flipping a fraction over. So another example would be if you have the slope of -2, the opposite of that is +2. The reciprocal, you have to view it as 2/1, would be 1/2. So these two slopes are considered perpendicular. So the opposite sign gets one to go one direction, one to go the other. The reciprocal, though, is what really forms this 90-degree angle in the middle. Okay, well, let's look at a few examples here. Determine whether these lines are parallel. So they look parallel right now, but we want to check the slope. So I have K1, K2, and K3. So let's do the slope of those three. So I'm just going to count rise over run. Since it's already on a graph, I don't want to make a mistake by subtracting the numbers. Let's just count. And everything's going up by 1 unit, so I'm good to do that. So the rise is 1, 2, 3, 4, and then my run is 1. So 4/1 would give me a slope of 4. All right, I'm going to go from here. I'm at 3, so I'm going to go up 1, 2, 3, 4/1. This one looks parallel too. Let's go from this point to the other point. So 1, 2, 3, 4, 5/1. Let me double check that. 1, 2, 3, 4, 5/1. Yeah, so that one is 5/1, which is clearly not 4. So the only two lines that are parallel are the first two. So let's bring back in the notation that we're using here. So I'm going to say K1, and let's use the parallel markings, is parallel to K2. Okay. So again, the key element here, parallel, you have to tell yourself, okay, that means their slopes are the same. So that's how you know how to proceed. Okay, let's go on to the next page. Okay, we're going to do a little graphing here on the next two. All right, number 3 says that line K passes through -1, -4, and 3, 6. Graph the line perpendicular to K that passes through -4, 3. Okay, let's graph K. So let's plot these two ordered pairs and make our line. So -1, -4. Here, and then 3, 6. 1, 2, 3, 2, 3, 4, 6. Okay, and I'm going to grab a ruler here. And I'm going to go ahead and graph it. All right, so this is line K, so I'll label a K over here. If I need the second line to be perpendicular, so I need to be knowing, well, what does that mean with their slope? So what I need to be thinking about is I need the opposite reciprocal of the first slope. So let's count the first slope. Okay, so I'm going to just do my rise over run here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then over 1, 2, 3, 4. So that is 10/4. So that reduces down to divide by 2 on both, 5 over 2. So I might recheck that real quick because I counted quite a few, make sure I didn't skip one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Okay. And you could also do the y2 minus y1 if you would like. All right, I need a new slope. So I'm going to put here perpendicular m. So I want the opposite and I want to flip it over. So I need to have a negative 2/5 as my new slope. And then I'm going to pass through this point here. So I'm going to graph my point, and then I'll count my rise over run off of this point. Okay, so I'll switch colors here. Negative 4, 3. 1, 2, 3, 4. 1, 2, 3. And then I want to count my rise over run, so I'm going to go down 2 over 5, down 2 over 5. Down 2, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4. Okay. And then I'm going to graph it, and it should look perpendicular because they have opposite reciprocal slope. All right, looks pretty good. So it's drawn to scale. It should look like you expect it to look. Okay, I'd like you to try, I want you to actually try the next two, 4 and 5. So why don't you pause the video, work through the next two, and then come back and check your answer with me. Okay, I'm getting this line on here. Oops. All right, this is on J. Need the slope. So it's a negative slope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a negative 1/5. So I need I'm still doing perpendicular. I need a perpendicular M. So that would just be a 5, or 5 over 1. Negative, or 0, negative 4 is my point. Oops, go down. 1, 2, 3, 4, and then up 5 over 1. So I'm going to turn that into a slope. So 1, 2, 3, 4, 5 over 1. Okay, and that is looking good. I'll put the line on there just to make sure. All right, now it looks perpendicular. So watch the word here, perpendicular versus parallel. All right, determine which lines are parallel. So I need slopes. So I'm going to do the y2 minus y1 formula here. So 7 minus 6, 4 minus 2. Okay, I'm getting a 1/2. 2 minus 1, 6 minus 0, 1 over 6. Oop, what am I doing? It doesn't reduce down. So that is different. So 3 minus 5, 8 minus 4, negative 2 over 4. Okay, so I got a 1/2, a 1/6, negative 1/2. So none of them are parallel. So it's a little bit of a tricky question because I would expect something to work out. But in fact, none of them are parallel here. Okay, so the big idea here that you need to get down is, what do you know about the two slopes? So same slope for parallel, opposite reciprocal for perpendicular, and then you can see we applied that to a variety of questions. Okay, that's it for this lesson. If you have any questions, feel free to send me a message.